In part 2 of the Pythagorean theorem video set, we are going to do 2 more examples. Example 3. The legs of a right triangle measure 15 feet and 10 feet. Find the exact simplified measure of the hypotenuse, and find the approximate measure of the hypotenuse rounded to the nearest hundredth of a foot. So I'm using the Pythagorean theorem. I'm going to start by labeling the sides of my triangle, which would be its legs. And the unknown hypotenuse I'll call C. I'll set up my Pythagorean theorem formula. C squared equals A squared plus B squared. And into that formula I will substitute the values that I was given for my legs, 10 and 15. Now work out and simplify the right side of the formula. When I get down to C squared equals 325, I'm ready to solve by taking the square root of both sides. However, when I try to take the square root of 325 on my calculator, I get a decimal value. I get C equals 18.03. That is my approximate value of the side length, rounded to the nearest hundredth of a foot. Now when I get my simplified value, I can also put that into my calculator to make sure I match the approximate value I got at this step. So when I have something like square root of 325 and I want to simplify it, we go back to what we learned in Supplement 1, where we look at our list of perfect squares and we check our list starting with large perfect squares and working our way to the smaller ones to see if we can find a perfect square that is a factor of 325. As I did this and I worked my way down, I found that actually 25 was the largest perfect square factor of 325. So I break 325 up into 25 times 13 to make 325. And when I take the square root of 25, that gives me out a 5. And I'm left with under the square root 13 remaining. So my simplified answer, that's still an exact form, is 5 square root 13 feet. And if I plug that answer into my calculator, I just need to make sure it also gives me that 18.03. That will help me know I did not make an error in my simplification. All right, I'm ready to do one more example of that sort. Example 4. Find the diagonal for a rectangle with dimensions root 12 inches by 4 inches. Again, we're going to find the exact simplified measure of the diagonal and the approximate measure rounded to the nearest tenth of an inch. I will again label my sides. In this case, I will draw in a diagonal that I'm looking for. I'm going to call that C and set up my Pythagorean theorem. I will substitute the values I was given into that Pythagorean theorem. And I'll remember, if I have the square root of 12 and I square that, square root and squaring are inverse operations, and I'll just get a 12 out. When I get to the step that C squared equals 28, I will solve that by taking the square root of both sides. Again, if I work that out on my calculator, I will get a decimal answer. That's my approximate answer. In this case, it's 5.3 inches. This problem asked me to round to the nearest tenth of an inch. I'm rounding to the tenth. Now, when I finish my simplifying of my root, I want to make sure I also get 5.3 inches if I put that into my calculator. So I have the square root of 28. Again, I'm trying to think of my list of perfect squares and find the largest perfect square that is a factor of 28. That is 4. If I take the square root of 4, I'll get a 2, and I'm left with a 7 inside the square root. So my answer for the exact simplified form is c equals 2 times the square root of 7 inches. I'll want to put that into my calculator and make sure I also get out that 5.3 inches, that approximate value that I calculated earlier.